Hello everyone, welcome to another video. And today I want to show you my new script which can do following things. And obviously the first thing which this script can do is to rotate and to align elements according to the location of the grid and the position of the grid. And in this picture here you can see that if you have some situation like this, when you run the script you will have result like this. And I did color these items just for you to see that the position of the air terminals will basically remain the same. Second thing which this script can do is that it can work in situation when you have multiple ceilings. So this is one room, but on the left I have one type of ceiling, and on the right I have some other type of the ceiling. And moreover, this ceiling here have, for example, height of 2,800 millimeters, and this ceiling here have height of 3,000 millimeters. So the script can handle this different ceiling elevation and different ceiling size. And another thing, the user can define what will be the offset from the wall. And I believe that in case that you want to align air terminals, that you will use this option, because air terminals will not work appropriately when you put them near to the wall. So you can see here that I did enter some value to push basically those air terminals from the wall, and you will have ability in the user interface to enter value which you want. And the last item from this slide, as you can see, the script is not limited to the rectangular rooms. So even if you have corners or some other complex geometry of the room, I'm sure that my script will be able to handle that. And now let's jump to Revit. So this is my sample project. As you can see, I have this room here. I have some rotation of the grid. Here I have 600 by 600 type of grid. Over here, as you can see, I have one room and two ceilings, and I have different types of ceilings. So here you can see that I have 1200 by 600 millimeters, and here I have 600 by 600 millimeters ceiling. Over here we have a simple room, and here we have another rotation with a different type of ceiling. And finally here we have a bit complex geometry. So let's see if my script can handle that. And before we jump to the Dynamo and align all those views, because Revit API have a limitation regarding the ceilings, you cannot create or modify ceilings inside the Dynamo. So basically, first of all, we need to export this view in the DVG into the AutoCAD. Then we will need to go to the AutoCAD and explode this surface pattern. And then we will run our second script, which will align those elements. And of course, we have a Dynamo script which will automatically export to DVG for us. This is our script. Basically, we need to determine what will be path of the file, which view we want to export, what will be the name of that DVG file, and we need to set true value for this question if we want to run the script. So now if I run my script, this is our generated file. Now we will open that file, and now we need to explode all those surface patterns. And the important thing for you to notice is the name of the layer. So this is our layer, and every time when we export DVG, all elements will be stored in this layer. And this is defined through your Revit export DVG settings. So if we go to Revit and for a moment go to the file, export, CAD formats, DVG. And if I want to modify export setup, and if I want to see what will be the name of my layer, and I can see that while exporting my DVG, the script did use this ISO standard. And if you click plus on this ceiling and look up for a surface pattern, you will see that the name of the layer always be like that. And that is important because you will need to know for our second script what will be the name of the layer from which you want to import geometry. I will close this now. We need to save our AutoCAD drawing. We can close it. And we can also close this script. But before I run that second script, I just want to show you what is the geometry in the Dynamo. So as I told you, we have a cascade ceiling in one room. So we have a ceiling with that elevation, and also we have some other ceiling which have different elevation. So now when we go to script and hit run, and the only item inside the user interface is this question regarding the offset from the wall. So if you want to offset the elements which you also want to align from the wall, you can just enter some value here, click on set values, and now the script is completed. So basically you can see that offset area over here, and you can see that this air terminal jumped from this location to this location, and you can see that also that previous position of the diffuser, now it's rotated. This diffuser is here. So basically every diffuser changed location, and if the diffuser also needed to rotate, it's rotate now. And for a moment I will close the Dynamo so I can lose all those dots and lines, and it will be easier for you to see new location of air terminals. And this is our result. So all locations are now aligned to the center of the grids, and also rotation, it's aligned to the rotation of the grid. And also if we take a look of the 3D view, we can see that all diffusers remain to be on the same height which they have before we run the script. And now let's go to script to see how that script works. And when we enter that value for the offset and hit run button, basically we will run this script. And this script does not have too much of the nodes, but it is a bit complicated, and I will try to explain this script the best I can. And first of all, let's see this group here. So this is the group of nodes which will actually import our DVG file. And for this block here, we need to have this file path, and in the script earlier and here we must have the same name for our DVG. We need to tell in which view we want to import this DVG, and we need to set some other options. And basically we'll then import our DVG in our active view, and we will pass that entire AutoCAD to this node here. And now if you remember, here we need to enter the exact name of that layer in which we are holding our surface patterns. And this node here will then convert that DVG element to lines. And you can see all those lines here. And from this point we can go here. Now we need to read all the ceilings that we have, and we need to intercept those lines with our ceilings. So first of all, we will call category of the ceilings, and we will read all elements that we have regarding the ceilings category. Then we will convert our ceilings to the solids. So we have 6 solids because we have 6 ceilings. Also, we will need to read the offset of those ceilings from the level. And here you can see that most of the ceilings are near to the 3 meter height, and we can read the value. Over here we will just flat that list. And now, in order to intercept our ceilings with those lines, because those lines have a z coordinate 0, we basically need to move all those solids down to the ground level. We will use this geometry translate node. We will say that the direction for that movement must be negative z-axis, and what will be the value for that translation, basically the ceiling height. And in this way we will bring down our solids to the ground level. And now from this point, the story is a bit complicated because now we have 6 ceilings. So basically we have 6 ceilings, but we have only 5 rooms. This is room number 1, number 2, 3, 4, 5. And the important thing is to sort the elements to show in the same order inside the Dynamo. So later, if you're building a list of available points in which you can align your elements, and you're saying for the room number 4 and the ceiling number 4, determine what will be the available points to align my elements. if the numbering of the elements is not correct, room number 4 will be this, and the ceiling number 4 can be this. So that is why it's very important to have the same numbering for all elements inside the Dynamo. And in order to do that, we must have this group here. So now we want to align ceilings and the rooms to have the same numbering. And after that, we want to intercept basically our ceilings with our curves or lines from AutoCAD. And the result from this node will be basically the lines which will align all the grids which we have in our ceilings. And before we move forward in the right direction, let's just explain other group which we have on the left side. So we did read ceilings, but because we want to align air terminals, we will also call categories for air terminals, all elements of category, and we will also convert elements to solids. And we can see here that we have in our sample project 22 air terminals. We will flatten that list of the solid elements. We want to know a center point for each solid. Why? Because we also want to bring those elements down to the ground level. That is why we will read X and Y component for the points. And when we say, okay, now build the points by coordinates, by using only X and Y, you can see that the Z component will be 0. So from those values here, now we have values with the Z component 0. Also, we will need later elevation from the level, so we want to know what is the elevation for each diffuser, because in our entire script we will bring all elements down to the 0 in order to compare their geometry, but later when we align elements we also want to give them their previous value for elevation. And this is our input zone. In our user interface we have only one parameter, and that is the text box data. Basically we just need to type in some value which we'll use then for determining that offset from the room boundaries. And now we also need category for the rooms, and we need all elements which we have for that category. We will also convert rooms to geometry, and we will flatten that list. So we have 12 rooms here, and we will intercept the rooms with basically air terminals. Why? Because we want to play only with rooms where we have air terminals. So maybe we will have 100 rooms, but only in 10 rooms we have some air terminals. So there is no need for Dynamo and for our script to play with all those rooms. And that is why we will filter only the rooms in which we have air terminals. How we will do that? Again, we will bring down all air terminals to the ground level in the same manner like we did it for the ceiling. And then we will pass air terminals to this geometry does intercept node, and the output from this comparison here will be this. So in these 5 rooms we have air terminals, and in those rooms we don't have air terminals, and we can check that. So room number 1, 2, 3, 4, 5, and yes, in those rooms we have air terminals. That is okay. And now we will convert rooms to geometry again, but we will convert only those 5 rooms to play with them in our script. And as I told you earlier, we will took now these 5 rooms and deliver that to this group of nodes up here in order to sort them in a way to have the same numbering for ceilings and for the rooms. And that is the explanation for this left part of the script. Now let's go to the right part of the script. And now how we will determine rotation angle for our air terminals. Well, first of all, we have all the lines which intercept our ceiling, and we do not need to deal with all lines from the list. We can take only the first line for each ceiling, and that we will do here. Then from those lines we need to create a vector to know the direction of that line, and we will compare that with the vector of x-axis, and after that we will have an angle. And because our air terminals have a square shape, we can basically subtract those 90 degrees. So in case when we have 90 degrees for some air terminals, we will not need to perform rotation of those air terminals. And in the end, because we have some float numbers, we just need to round that in order to have integer. And this will be the rotation angle for each ceiling and for all air terminals on that ceiling. This group of nodes here basically need to determine what is the size of the grids for each ceiling. And first of all, I want to group parallel lines because I know that for each ceilings I have a grids. Grids have basically two types of lines. And basically if you look any ceiling, so for this ceiling here I have this group of line, and of course they are parallel, and we also have these like horizontal lines, and those lines are also parallel. So when I deliver those lines to these nodes here, basically this node will create two subcategories for each ceiling. So let's say first subcategory will be horizontal lines, and second sublist will contain vertical lines. Okay. And from this point, I decided that this upper part of this group of nodes will determine the length of the grid, and this group below will determine what is the width of the grids. And basically this is the get item by index node. Just I did rename that node to be a length and this node to be a width. And for this one I did say, okay, you will get these horizontal lines and you will get those vertical lines from this sublist. Now we did took this horizontal portion of the sublist, and now we basically want to measure the distance between two lines, and that will be the length. And also if we done the same jump for the vertical lines, when we measure the distance between two vertical lines, we will have the width. Okay. And now I did took first and second element up here and down there. Now I want to measure geometrical distance. You can see what is the distance for each ceiling. Because I have some decimals here, I want to round those numbers. And in that way I did determine A and B part of those grids. And now this is like key for this entire script. When I determine all central elements for each grid, then I have a pool of all available points in which I can store my elements. And basically what you get from this DVG file is interception of the lines. So from DVG you will have this point here, this point here, this point here, and this point here. But actually what you need in order to align those elements is the central point of the grid. And now when we know the size of the grid and we know the vector, we know the direction of those grids, we can say, okay, for each ceiling, let's go the half of the grid in this way and the half of the grid in this way, and I'm sure that I will have the center point. So what is the start point for this node here? The start point is this curve intercept all. So for the moment, if I show you those points here, so what you will have from this node here and from the DVG is actually those points here. So when two lines intercept, when the grids intercept, we will get to know these points here. So this is our start point. And now we say, okay, we know the direction of the grids, and we are saying now, okay, let's go horizontally for the half of dimension of the grid, and that is now our new endpoint and start point for this lower part of the group. And then if we deal with the horizontal part of the grid, now we go to the vertical part of the grid, do the same. And here basically we have the center point of all grids that we have in our project. So you can see that in this sample project I have almost 600 points and 600 grids. And this is now basically the pool of available center points of the grids. Then, as I told you, basically I don't want to have situation when my air terminals is very close to the wall, because in that situation my air terminals will not work appropriately, and that is why I want to offset that room boundary from the wall, and that is pretty easy. So basically when you have rooms, you can easily extract room boundary, and now when we took all those lines and pass to this polycurve by joint curves, in order to join all those curves, we will flatten that list and we will connect that to this curve smart offset node. And if you remember, we did say that we will give user freedom to enter that offset. So in this script I did type 1000 and I will read that, and in order to make internal offset of the room, I will need to multiply my value with -1, and now I will pass that information to this curve smart offset, and in that way I'm sure that I will have proper offset, like you can see here. This is like pool of all available points in which we can move our elements. But if we want to use that offset function, we need to reduce that pool of numbers. So basically we will now intercept our pool of available points with our offset. And when we filter all points which does not belong to our offset, at the end we will reduce that number of points from 600 to 300. And now, before we move forward to the right, let's see what we have here. So we did group air terminals, and in this way, for each air terminals, now we know in which ceiling they belong. So we have group for the ceilings, and now we will sort that group, and in the end, we did sort our elements according to the ceiling. Again, we have 305 points in which we can store our air terminals, but first of all we need to determine which point we will took for our new location and how we will find new point. And basically the logic for that final group of nodes is, so if the center of my element is here and the closest center of the grid is over here, I will measure all possible variations in which I can store my element. So if this is the closest point and if this point belongs to that new offset, I will then store my element over here. So we will measure the distance between our air terminals and all available points. Then we will use this node here to get information regarding what is the closest point for each diffuser and what is the index for that point. Then we will took those points, but because our points have 0 for the z component, we need to split to divide those points to x and y and to add information for that z component. And if you take a look, those values will be new values for the z component. And now when we have our new points, it's very easy to set new location for the air terminals. And also this node here, it's a very simple node. So already we did determine what is degree for each air terminals if we need to rotate that air terminal, and we will pass that list of family instances, and this node will rotate our elements. And that's it. Thanks for watching. Bye.